Hi everyone, welcome back. So let's continue to do the following example. Find the component form of the vector v with given length and angle theta made with the positive horizontal x-axis, okay? So we know that, well, have you learned polar coordinates? I hope you did in Calculus 2, right? So chapter 10, we're in the polar coordinates and we talk about polar function, etc. Okay, so here, so we have a r here, let's say. Okay, so for polar coordinates, we have the r and the theta we make with the positive x-axis. Okay, so here we have the vector v. Okay, and so this guy is 0 degree, and this is pi over 2, and this is pi, and this is 3 pi over 2. Okay, and now we have this is v. Okay, and this is theta. Well, then what is the x? Well, x coordinates is like the adjacent of this triangle. Adjacent over hypotenuse is cosine, so it's the magnitude of v times cosine theta, and then we have the y. So y is opposite over hypotenuse is sine, so this is the magnitude of v times sine theta. Okay, so it's very similar to the polar coordinate we learned before. X is r cosine theta and y is r sine theta. And in this case, r is just magnitude of v. Okay, so let's see here. So x is 7 times cosine pi over 6. What is pi over 6? Well, cosine graph starts with 0. Okay, this is pi, and this is pi over 2. Pi over 6 is right here. Okay, so pi over 6 is right here. And what do we get? This is 7 times root 3 over 2. Okay, so 7 root 3 over 2. And then the y is 7 sine pi over 6. Sine graph. What is sine graph? So sine graph looks like this, right? This is pi over 2, and then pi over 6 is right here. So this is 7 times 1/2. Okay, so 7/2. So v is, the x coordinate is 7 root 3 over 2, and the y coordinate is 7 over 2. So for the special angle values, I hope all of you can remember it, okay? What are those special angle values? Let me see. Let me create more space here than I can show you here. Oops. Okay, so I want to, okay. Okay, so let's see. Okay, so okay. So let's move up a little bit. Okay. All right. So let me just move them up a little bit. Then I have more space to show you here. Okay, let's use a different color. Which one do you like? Let's pick something else. Yeah, I've seen green a lot. How about purple? Okay, so we have the angle. Okay, let's see. We have the angle theta. Okay. Sorry, something wrong with my word. Let's see. Okay, so we have the theta, and we have the angles 0, pi over 6, pi over 4, pi over 3, and pi over 2, right? We have sine theta, cosine theta, tangent theta, cotangent theta, secant theta, cosecant theta. Okay, so what is sine? Well, remember the rule, square root of n over 2. So the first one would correspond to n is 0. So 0 is 0. Here we have square root of 1 is 1 over 2, and then square root of 2 over 2, square root of 3 over 2, square root of 4 is 2, but 2 over 2 is 1. Okay, so this rule can help us to figure out the first rule. For cosine, it's the same number but reverse order. So that's why 1 square root of 3 over 2, root 2 over 2, 1/2, and 0. And then how do we figure out tangent? Well, tangent is sine over cosine. 0 over 1 is 0. 1/2 over root 3 over 2, the 2 cancel, so 1 over root 3. Root 2 over 2 over root 2 over 2 is 1. Root 3 over 2 over 1/2, the 2 cancel, we get root 3. 1 over 0, but this is, we know 1 over 0 is undefined, but 1 over 0 plus will give us infinity, 1 over 0 minus will give us negative infinity. Okay, so this is, we can say undefined. Or you know there is a vertical asymptote there. Okay, so let's put this to denote. Okay, undefined. We know there is a vertical asymptote there. Well, cotangent is the opposite, the reverse order of tangents, right? So undefined, root 3, 1, 1 over root 3, and 0. Okay, and then how to figure out secant? Well, secant theta is 1 over cosine theta. Okay, so I hope you are familiar with those trig identities. Okay, so let's look at cosine. Cosine is this guy. 1 over 1 give us 1. 1 over root 3 over 2 is 2 over root 3. 1 over that is root 2. 1 over that is 2. 1 over 0 undefined. Okay, and then cosecant is the same values but in the reverse order. So let's just copy it here. And then now we finish the table. So far so good, everybody? Okay, let's continue. So the magnitude is 11 and the theta is 225. Okay, so what is 225? So this is 180 degree, right? And then 180 degree plus 45 degree is 225 degree. So 225 degree is in the third quadrant. Okay, so x is 11 times cosine 225 degree. Well, the value is the same as 45 degree, but it's either plus or minus. Okay, it's in the third quadrant, then the sine is negative and the cosine is also negative. So this is negative 11 times, what's cosine 45 degree? Root 2 over 2, so minus 11 root 2 over 2. Y is 11 times sine 225 degree, but it's the same thing. In the third quadrant, sine is negative. And sine of 45 degree is root 2 over 2. So we also have 11 root 2 over 2. So V is minus 11 root 2 over 2 and minus 11 root 2 over 2. So far so good, everybody? Alright, let's continue. Find the component form of the vector V given that the magnitude of U is 9 with theta equals pi over 3 and the magnitude of 2u plus 3v equals 4 with the theta is minus 7 pi over 4. Okay, first of all, we want to figure out the components form of u and the 2u plus 3v. Okay, so let's see. U equals, so x coordinate is 9 cosine pi over 3, 9 sine pi over 3. So pi over 3 is 60 degree, right? And 60 degree, let's see. So, okay, cosine is right here, and sine is right there, and then for pi over 3 right here. So cosine is 1/2, sine is √3 over 2. So far so good, everybody. Then we have 9 over 2, and then 9 √3 over 2. That's the u. And how about 2u plus 3v? Well, that's 4 times cosine -7 pi over 4, and then 4 times sine -7 pi over 4. Okay, so what is -7 pi over 4? Don't you know cosine theta is cosine of the theta plus 2 pi. And same with the sine. So -7 pi over 4, when you add 2 pi to it, is the same as pi over 4. Okay, so this guy is the same as 4 cosine pi over 4 and 4 sine pi over 4. So we know cosine pi over 4 is √2 over 2. And here sine pi over 4 is also √2 over 2. 4 and 2 cancel. We have 2 √2, 2 √2 here. So far so good, everybody. Alright, how do we find v? Okay, first of all, we know 3v equals 3v equals the 2u plus 3v minus 2 times u. Okay, so 2u plus 3v is 2 √2, 2 √2, minus 2 copy of u, which is 9/2, 9 √3 over 2. So we have 2 √2 minus 2 cancel, 9, 2 √2 minus 2 cancel, 9 √3. Okay, so what is v? V, we can divide it by 3. So we have 2 √2 minus 9 divided by 3. 2 √2 minus 9 √3 divided by 3. So this is the component form of v. So far so good, everybody. So don't forget, if you have questions, you can always print screen and then ask me in class or in office hours, or email me, okay? Next, so geometric intuition, if u and v are vectors, then the scalar projection of u onto v is given by the expression u dot v divided by the length of v. Okay, why is that? So let's draw some picture. We have u here, and we have v here. Okay, then we know the length of this guy is the magnitude of u, and this is the angle between them. Okay, so if we consider, we write a line segment perpendicular to the vector v. Okay, then what is this guy? So we talked about that in our first video. This is actually the magnitude of u times cosine theta. Okay, so it's the component of u in the direction of v. And this is actually the scalar projection. Okay, so scalar projection equals u dot v over the magnitude of v, this is the same as the magnitude of u times cosine theta, and it is a number. Okay, this is scalar projection. And next, for the projection of u onto v, it is a vector. Okay, it is a vector, and the length of it equals the component of the u in the direction of v, and then the direction is in v. So that's why you see this unit vector. This is the unit vector in the direction of v. Okay, so that's why we have the length, we have the direction. So the result, the projection of u onto v is a vector. It is not a number. However, the scalar projection is the length of it, so it's a number. So far, so good, everybody. Okay, let's continue. Let's look at the following example. Find the projection of u onto v and the scalar component of u in the direction of v. So first, let's figure out what is the component, the scalar component. Okay, so u dot v equals 6 times 2 minus 7 times 5, 3 times minus 3. So please stop the video and try this problem first, and then continue to play the video and check your answers. In this way we can practice, right? And then we get minus 9, so that's 3 minus that, so negative 32. So far so good, everybody. And what is the magnitude of u? Well, magnitude of, actually in this case, to find the scalar projection, you only need to know the length of v. Okay, we don't need to know the length of u. Okay, so this is square root of 2 squared, 5 squared, and negative 3 squared is the same as 3 squared. So we have 4, we have 25, we have 9. So the answer is square root of 38. And then what is the scalar component? Or scalar projection equals u dot v over the magnitude of v. So that's negative 32 over square root of 38. So far so good. How about the projection? How about the projection of u onto v? So that is u dot v over the magnitude of v square. Okay, and then times v. Okay, so this is a number. Okay, so this is a number, a scalar, and then this guy is a vector. Okay, so all together will give us a vector. So u dot v is minus 32. Magnitude of v squared give us 38. And then v is 2, 5, negative 3. So far so good. And we can actually do some cancellation. 32 and 38, we can cancel the 2. Then we have 16. Here we have 19. So minus, and then we multiply each coordinates. 2 times 16 is 32 over 19. 5 times, okay, we can, okay, so we can multiply by it. So negative that, oops. Okay, so negative, and 16 times 5 is 80. 80 over 19. -3 times -16 is positive 48/19. Okay, so this is a vector, this is the projection of u onto v. So far so good, everybody? Okay, so this is how we find the projection of u onto v and the scalar components. And let's continue in the video part C. See you soon!